Okay guys, I want to go ahead and explain how to do these calculations on the linear velocity lab. Here you can see that I have a circumference of 8 inches. My time will be 14 seconds. You have to do an average of all your different times. And the distance I decided to use an example is 22 feet. Therefore, my distance is actually 264 inches. The reason why we want to have it in inches is because my circumference is in inches, as well as so my distance needs to be in inches so my units match up. Alright, let's dive into this. One thing that we know we're going to need is the radius of the circle, and if we know the circumference, we can actually calculate our radius, because circumference equals 2 pi r. If we know circumference and we're looking for r, we just substitute things in. So our circumference is 8 inches. That has to equal 2 pi r. Divide both sides by 2 pi. And that's going to give us a radius of 4 inches divided by pi. And I'll go ahead and simplify this later on in the process. The next thing we're going to have to do is we need to go ahead and calculate our actual linear velocity. The formula we're going to use to calculate linear velocity is going to be distance equals rate times time, but in this case our rate is linear velocity. So we can actually rewrite the equation as d equals vt, where v is actually our linear velocity. From here, we just kind of plug everything in. We know our distance, we know our time. Our distance is 264 inches equals my velocity, linear velocity, times my time, which is 14 seconds. From here, we divide both sides by 14 seconds. These cancel out. And when you put 264 divided by 14 in there, we'll get that v, our linear velocity, is approximately 18.86 inches per second. Okay, so from here, we're going to actually use this bit of information . We're going to use this bit of information, and what we'll have to do is actually use it to find our angular velocity. Our formula for angular velocity is going to be my v equals omega times my r, and this time it's actually radius. So we know our radius from over here on, let's see, let me copy and paste it over. This is my radius. Alright, so our radius is 4 inches over pi, and our velocity is 18.86 inches per second. And what we're going to do is we're going to use our velocity, our linear velocity, because we know that's angular velocity times the radius. And we're going to basically just solve the same way. We're going to do 18.86 inches per second equals my angular velocity, which is omega, times 4 inches divided by pi. Now, we go ahead and divide both sides by 4 inches divided by pi. It's going to look a little ugly, so I'm going to go ahead and just really multiply the unit by the reciprocal. So if I have an inch, I'm going to do 1 over inch. Now, this is 4 pi inch. This is the radius, and every radius, 1 radius equals 1 radian. So we're actually going to take this and convert everything over to our angular velocity. We are going to get my angular velocity is 18.86 inches per second times 4 divided by pi radians per inch. My inches will cancel. And once we throw all this into a calculator, we're going to get that my angular velocity is approximately 14.81 radians per second. Now we are going to have to use this bit of information right here to actually calculate out our RPMs, our revolutions per minute. So we have our angular velocity is 14.81 radians per second. The equation that I will need to use will be my angular velocity equals my RPMs 2 pi, and this is of course radians per revolution. From here we just plug everything in. We have 14.81 radians per second equals theta 2 pi radians per revolution. We simply just do a little bit of math. We would do 14.81 divided by 2 pi times radian per second times revolution per radian. And that is going to equal my RPMs. My radians cancel out. And that's going to give me 2.36 revolutions per second. Now we want to do revolutions per minute in this, so we need to convert seconds to minutes. That's pretty straightforward. We are going to do 60 seconds over 1 minute. My seconds cancel. And once we throw it into the calculator, we will get 141.6 revolutions per minute. These are all the calculations that I want. There are 4 different formulas you would have to put onto your lab report. The first one is going to be, well, one's going to be right here. The other formula is going to be right here. The other formula, of course, is circumference. And then my other one, you can actually, if you give me D equals VT or D equals RT, they're the same thing, just with a different variable written in. So I would be looking for all 4 of those on your lab report.